All right, ladies and gentlemen, welcome back. Here's another installment of Lab Safety, trying to keep you safe in the lab, trying to keep you in the know so you don't hurt yourself. We're going to take a look today at some GHS pictograms and some NFPA symbols. You'll understand this. This is just kind of general guidelines that you'll look, and they're either a picture of something that's going to tell you how it's going to treat you, the chemical, what it's going to do to you, or it's what I've got here. This is our NFPA diagram here, and we're going to go through what the numbers inside of this or what the symbols inside of this actually mean. All right, I shouldn't have put that there. I'm going to go ahead and erase that because I'm going to put some stuff over here. All right, first, the red area I'm going to do over here. Red is all about flammability, right? So is this element or this chemical flammable? And it's talked about the flammability hazard. Let's get this little guy out of the way. And there's actually just four numbers here. There is 4, 3, 2, 1. I guess there's 5. And so we're looking at this, and for 4, it's extremely flammable, which means it has a flash point below 73 degrees Fahrenheit. So 73 degrees Fahrenheit or below that is actually going to cause this thing to ignite. And so if something's extremely flammable, if you put it inside your house, it's going to blow up. Because last time I checked, most of you turn your thermostats up in the middle of the day past 73. All right. The number 3 is going to tell us that it is a serious flammable. The flash point here is between 73 to 100 degrees Fahrenheit. The second one is moderate. Moderate. There we go. Put an E in there. And this is a flash point below 200 degrees Fahrenheit. And then slight. Slight is slightly combustible, requires strong heating to ignite, which means, hey, we're going to have to put an open flame to it and hold it on there before it's going to go. And then for 0, this would be minimal, which means it's not going to burn under normal conditions. So even if we put it in a flame, it's not going to catch on fire. All right, so flammability, we'll be dealing with anywhere from 0, 1, 2, normally not 3 because we don't want something igniting at room temperature. So we're going to stay between the 0, 1, 2s is what you'll see. If you see anything 3 or 4, don't open that sucker up. And keep it in the fridge. Okay, so now the yellow, or sorry, let's go blue. Let's go health hazards, because generally health and fire are really what we're looking at here in general chemistry. And again, it goes 4, 3, 2, 1, 0 here. So I'm going to go 4, 3, 2, 1, and 0. And 4 is extreme. So it's extremely hazardous, which means it's highly toxic, may be fatal on a short time, or even with short-term exposure. So like if you spill it on you, even though you wipe it off immediately, something that's extremely hazardous could still kill you. So probably not going to see anything like that here. For 3, it's serious. And for something that's seriously a health hazard, it means it's toxic, so we want to have full protective suit, and breathing apparatus should be worn, which means we want to protect ourselves to the utmost extreme when we're dealing with something that's a serious health hazard. For 2, it would be your moderate. So those are moderately considered health hazards. So breathing apparatus, face mask must be worn. We want to protect our organs. Generally, with that, you're going to try and avoid exposure with your hands and with your skin as well. Number 1, this is slight. And so breathing apparatus may be worn. And again, we're going to kind of protect ourselves with probably some skin conditions. We're trying to keep or reduce exposures on our skin. And then for 0, this is minimal, no precautions necessary, which means you can probably eat it if you wanted, but we're not going to eat anything in chemistry. And so if I'm looking at something here and I have something that's 4 and something that's 3, and the numbers just appear there in black, so if I had something that was 4 there, that means it's going to blow up at room temperature, and then when it blows up and spreads everywhere, it's going to kill me. Don't want to mess with that guy. All right? Don't want to be there. So now we are going to do, I'm going to use a different color yellow here so I can make sure that we see. This is instability, is the yellow. And so instability means, again, it's a 4, 3, 2, 1, 0. And it's extreme, serious, moderate, slight, and minimal. Same kind of things. For instability, this would be explosive at room temperature. So for our extreme, would be explosive at room temperature. For 3, our serious, we're looking at may detonate if we hit it. So a lot of people know nitroglycerin is this. If I threw it against the wall or dropped it on the table, it could actually explode. And we don't want it under confined or mixed with water. These guys, moderate, unstable, may react with water. So we want to keep 2, 3, and 4 away from water, definitely. Then we get to slight for number 1. So it may react if we heat it, or it may react if we mix it with water. And this is kind of a may, not a definite. So we'll probably get smaller reactions. Definitely not explosive. Definitely not something that we're going to have to worry about. But we want to be aware of it. And then for minimal, we know that it's normally stable and doesn't really react with water. So we like the zeros. So generally, if we see something that's extremely flammable, health hazard, it's probably going to be relatively unstable a lot of the times too. So we want to stay with that. But again, the number would appear right there. Now, when we get to the clear one, these are our specific hazards. So these are specific. And these are actually just going to be just some abbreviations. We've got oxy, which means it's an oxidizer. It's going to help react some things explosively at times. Acid, goes without saying, it's an acid. Alkali, which means it's going to be basic. So it's going to be a base and react like bases do. Corrosive, something you definitely want to watch out for with this one. And my acid and my alkali are also corrosive. But this means it's going to eat your skin. If it's corrosive, or it's going to eat the table or eat substances and kind of react them away. Then a big one too that you definitely want, if you see a W with a cross through it, don't get that thing near water. All right, because it'll explode with water. And then the radiation symbol is 3 triangles. We all know that just means it's radioactive. All right, so you'll see those in the white area here. A lot of the times we're not going to have any specific substances or specific hazards there. It'll be clear. So, all right, so we're going to go ahead and clear this out here. We're going to jump on to the GHS pictograms. There's 9 of these, and I think I'm actually going to save and just show you these. You just need to know that there's 9. They generally are depicting hazards. We'll do something with class in them. You definitely want to know what they are, but we have health hazards, we have flammability hazards, we have the exclamation mark, which means it is another form of health. Gas cylinders, corrosion, explosives, oxidizers, environmental things, and then also acute toxicity, which means that's our extreme hazard. But the GHS symbols and the NFPA symbols are all going to tell us some of the same information as far as how do we want to proceed with this particular chemical. All right, so again, trying to keep you in the know, trying to keep you safe. We will definitely go over these GHS standard pictograms, and I'll have that and the NFPA posted in the room so that you can keep yourself safe. I'll see you in class. Make sure if you have some questions, you write them down.